Quantum mechanics is a well-known but misunderstood branch of physics. But did you know a lot of the weirdness has nothing to do with quantum particles? Let's take a closer look at Heisenberg's uncertainty principle. It states that we cannot simultaneously know both the position and momentum of an object. The more we know about one, the less we know about the other. Now you might wonder why we can do that for a car. We can determine the position and momentum for a car because of the car's size. Let's take a closer look at the formula. In this formula, delta P is uncertainty in momentum, delta X is uncertainty in position, and H is Planck's constant, which is a very small number equal to 6.6 times 10 to the negative power 34. Now you might wonder why we don't see any of this affected when we measure the speed of a car. That's because the uncertainty value is so small that it doesn't affect our measurements. Quantum mechanics tells us that the position and momentum of an object don't exist. Rather, what exists is a wave function that tells us the probability when we measure it.
When we consider very small objects, they behave like waves and particles. In this experiment, the electrons did not form clusters as expected, but an interference pattern, just like a wave.
This is why Heisenberg's uncertainty principle makes sense. Waves cannot tell us position and momentum simultaneously. This is not an error with our measuring devices, but rather it's a fundamental restriction of our world.
The way our world works may be counterintuitive and illogical, but it is the truth.